Hi everyone, welcome back. This is the writing a programming language in Rust stream. I'm currently working on the last few bits of this kind of research based programming language that that I am calling Seed, and it aims to more or less include language features that are fairly typical at this stage in a lot of modern languages, but that will then be used as a basis for other languages that might have some more novel features or ideas. The current feature that I'm working on today, I was just recapping my notes on where I left it last time. So I'd like to take a look at fixing the operator assignment with non-variables. I'll be explaining that shortly. Now it could be a bit of a hairy one, so I have some... Oh, where have they gone? Oh, up here. I have some other follow-on little to-dos that I need to take care of at some stage as well that I might fall back to depending on the complexity of today's task. Sometimes the amount of headspace that I have for a given problem can kind of fluctuate during the session, so I have some fallbacks if needed. So that's the project. The environment that I do all of this in is a remote Linux environment. I connect to it using Mosh to create a stable connection. I use tmux to split it up into different sessions and get these window panes that you see here. I use a more or less vanilla Vim setup with custom configuration, and the only plugin I really use is this plugin called NerdTree, which I use for file browsing. On the right hand side, I use ENTR to rerun tests and rebuild the project whenever files change. And then in the bottom left, I just have again fairly vanilla bash setup, which I use for just running Git and things like that. So yeah, that's more or less it for the setup. And like I said, today I'm hoping to work on this idea of fixing operator assignment with non-variables. So what's operator assignment? It's what I'm using to refer to these kind of simplified operations where you do an assignment and an operation in the one go. And that is maybe a little more complicated than it needs to be because of how I've actually implemented the language, because I've potentially overlooked something quite simple. And I was just recapping a few minutes ago what it might look like to fix this, and essentially what we're going to be looking at here is this section where the language actually performs assignments. And I can see that where essentially this is where there might be a bit of a, I guess, suboptimal approach being performed in the language, and that's being called. So the structure of things so far is that each block in the language will introduce a new scope, which is just a hash map from names to values, and the values are also paired with the location that they came from, and the scopes are then structured in a stack. So whenever a block is entered, that will push a new scope onto the stack, and when we're declaring a new variable, then that will we'll work our way, well, it depends. If we're declaring a new variable, then that will go onto the topmost scope of the stack. But then if we're assigning to an existing variable, then we'll go up the stack in reverse order, essentially stack order, to find the topmost scope that contains that name, and then we'll attempt to assign to it. And this is where that value is assigned to, and I use air quotes there, even though it feels weird to do it, feels like a very dated gesture, but the action that we're performing in this instance is to not actually update the box. So even though each value essentially in the language is put into a box, which is this valref with source, which is an archimutex value. So it can be shared across threads, but it's can only be accessed in a mutually exclusive way. Essentially, we have this memory safe box, but with the, shall we say, the assignment primitive that's being used for this language, when we're assigning to a value rather than declaring it, what we'll actually do is in the scope, we'll replace the box that name is referring to with the new value. However, what we should in theory be doing is actually replacing the value inside that box. And not only will that actually potentially simplify a lot of the, well, I'd actually have to work through it to find out for sure, but it could end up simplifying a lot of the code around binding and assignment. But most important for what I'm working on at the moment is if we have an assignment like this approach makes things a bit trickier, because if we want to define this in such a way that X only gets evaluated once, you can take a look at our earlier streams where I go into a bit more detail on why it will be it could be evaluated multiple times if we take a naive approach to this feature. But in short, this is the thing that would need to change. We would need to change this to, instead of replacing the box, to actually replace the value inside the box. And I can see, and I only took a look at this comment a few minutes ago again, that I have a comment here actually addressing that and saying this should ideally overwrite the value stored in the variable instead of introducing a new variable with a new binding. But this isn't possible at present with the current structure of valref with source. And this is very interesting because it says, see the comment above, valref with source for more details. And I go to, where is it, define value, valref with source, go to the definition of that down here, and we can see, like I was mentioning, it's an archimutex of value with source, and there's no mention of the issue that I was describing here. So what I might, I can close that. What I might do is take a look at the old instance of this project, which is at Norpal on GitHub. And what branch would this be on? I would say this is probably the most, well, let's take a look at the branches, see what has the most activity on it. I presume they're all stale. And this one seems to be the, Laurel tests. This is the one that has the most activity on it, and maybe that will contain the description above valref with source, and it doesn't. So let's take another, we won't spend too long on this, we'll just see if we go back a little bit if it contains the mystery information. Let's see. Source, would it be in eval, I would guess. Back when everything was basically just in one file. No, even back then I had already gotten rid of that comment. So yeah, that just seems to be a stale comment. I think it doesn't happen too much or too often, but that is a pity that the thing that it's referring to no longer exists really, or at least the reference is broken if the information still exists somewhere. Let's see where. Maybe if I do a blame and we'll go down to where was valref with source, it was around here. So here added support for this. And maybe if I take a look at the parent and browse the files at that point in time before that changed, then maybe. And the values are going to be, or the names are going to be different at this point. Is the comment even going to be still the same? When did I even write that comment? That could be something worth taking a look at. So what's the comment itself? It's above a sign. Yeah, and so that occurs there. And we don't have it here. And so we have a to-do comment here. Note that a value source should ideally be stored with the value inside the mutex. Okay. That reference is referencing something different though. So it seems like that was a bit of a red herring. So really that comment was fairly irrelevant. And in fact, I would say this much is the part that's relevant. Let me just charge this. There we go. And so, yeah, with that in mind, let's take a first stab at just replacing the variable straight up. So we're going through all of these, and if we find a layer where we can make an assignment, we can probably restructure this a little. So what we're going to do instead is, I'm actually not fully sure what location refers to. Oh, location is where the variable was defined for debugging purposes. And for stack trace purposes, I presume as well. So we have our location and we'll have the variable. So what we'll do is we'll So we're keeping location as is. So the variable, when we assign to it, the declaration point doesn't change. So so we can actually ignore that, and instead we can do something like this. I don't think that this will necessarily work without some extra magic. Now what I might need to do is also deref that. Okay, let's try that. Even though it would be a fairly significant change, it's still only a patch because it is more of a refactoring than an actual added feature. So expected an arc but found a mutex. So I wonder if I did that, even though that would seem a little strange to me, but we shall see. Now, what's going on here? Is it after hanging because this will cause deadlock? Like, is it attempting to compile and then run tests immediately? Just a moment. And we're back again. I'm not entirely sure why this took so long to compile, but however, so we have x is an ampersand reference, so the data it refers to cannot be written. Can we do it like that? So it's saying data gets moved, but we're not. Are we wanting to move it? We can possibly just copy the. Although, so we have the. Whoops. We have the scope at this point, and that's been unlocked. Now, the value that we're referencing is inside an arc mutex at this point. So let's call it that for the time being. So at this point we have, let's see, an arc mutex. Can we assign a type to it at this point, I wonder? I'm not sure. But at this point, arc mute should essentially be that. So if we were to try to decompose it like this, it might be an issue. And so instead of that, well, sorry, it's not that, because the thing that we have is actually a tuple, so actually that wouldn't really be a problem. So we would have the valref with source and the location. So that's actually kind of fine, and we'll add some of this decoration for the moment to help us try and keep track of things. Okay, so at this point we have a value with source, and we have a value with source at the stack level, but then our parameter is a value reference with source. So, but then that's the same thing. Yeah, so both of those are, can I just comment that out for the time being and say that oops, those are like that. That seems fair. But maybe we'll have to add in a mutability marker. Okay. Yeah, as might be apparent, I'm not fully sure how the mutability markers get inserted around these guys, because there's the variable declaration part for the bindings, but then there's the actual type definition. I guess it's just for the bindings, now that I say it out loud. Okay, expected. So because I've added in mutable there, and I think we're kind of back to where we were a few minutes ago, but at least with the type annotations it might give a little more insight. Yeah, so the data moved at this point, and the move occurs because VWS doesn't copy that. I mean, it would be possible to clone that. Is it a problem that it moves? Can't move it out of a shared reference. So can I make it a mutable reference? So the data is moved there, and we cannot move it out of a shared reference. So this presumably is our shared reference. That doesn't have the copy trait. Maybe we could clone that. Seems a bit cheeky. Since we're only cloning it so that we can get past the movement issue. Cannot move out of a shared reference. The move occurs because VWS has that type, and that type doesn't implement copy. And part of the issue is that it's a shared reference. Can I get a unique reference like that? Is there something like that I can do? Just say that I don't want it to be a shared reference. You might need to get, I don't know, something like ChatGPT in here, just because I don't use Rust often enough to be able to debug this on my own, I think. And it would just be that bit easier. Like, I could potentially just keep hacking away at it myself and figure it out eventually, but when the oops. Why is, oh, there we go. How do I get rid of those list characters? Because if I copy paste that, they'll be brought over. That should be fine for the moment. So let's see. Let's see, can I add some so I think ChatGPT can be used anonymously. So let's see what kind of prompt we want to work with here. So let's see. Now the formatting is a little messed up because of the end of line markers. There has to be an easy way of handling that, but for the moment this should be fine. Okay, so this gives the the error. Cannot move out of a shared reference. And we'll copy that part of the error as well. There we go. Yes, when you attempt to move value from a reference, you can't do that because you don't have ownership of it. That does not implement copy, so it prevents the move. And it's saying deref mutable is required to modify. And I have code that is updating a value in a reference in an arcmutex somewhere else as well. I wonder, can I get any insight from that? I'm not sure where that code is actually happening. Anyway, possible workarounds. Let's see. That's a lot of code. Instead of trying to move the value out of VWS and V, you can use a different approach to update the value. Since they both are that and they both wrap in mutex, you can directly lock both and mutate the inner value. Yeah, that's exactly what I'm trying to do. Okay, so that's the magic sauce that I'm missing, is I should be locking the value again. Now, there is the issue of potential deadlock when there is code like that, I believe. But for the moment, let's just give that a shot. Because it might be worth, if I'm cloning that data anyway. Now, I'm not fully sure why it's cloning the data from here. Maybe it's because I'm doing the deref. But that's still happening. Am I missing something? Lock the existing value, lock the new value, and copy the inner value, which is exactly what I'm wanting to do. And if I get rid of that, yeah. And can I also, oh, that's cool as well. So basically all the tests are passing, which is a very good sign. I mean, it usually is, but I was wondering, could it flag some subtle issues? Now that's interesting as well, though, that the operator assignment like I hadn't realized that I had an operator assignment feature. Oh, I have a very basic one, I think. So if I go maybe test CLI, no, standard out, operations, op assign 2. And instead of 2-1, I get 1-2. So that's interesting. I mean, it's funny that got flagged because that's the feature that I'm doing all this in order to enable. But we'll dig into the guts of that shortly. For the moment, though, I wonder, can this be simplified a little bit? Okay, so I wonder if there's potential issues with deadlock here, so maybe it's worth just thinking it through a little. So in this instance, we're basically taking one, I guess the main issue here, the main circumstance we would want to be careful around is if VWS and V are the same box. And so attempting to unlock it twice will be an issue. When could that happen? If we did something like x equals x. Then we could possibly attempt to unlock the same arcmutex twice. But this essentially is a no-op. So if it's possible for us to actually, instead of if it's possible to attempt a lock and then fail gracefully with a return code, if it's not possible to get the reference, and then we can assume that it's a shall we say we can assume that it's this kind of an issue. And now these kind of runs aren't fun. Well, that's kind of fun actually, because it does seem that we've hit deadlock. So the test is hanging. Now it's not fun because this will potentially be a pain to rerun, because I think the process likely isn't going to have been cleaned up properly. So yeah, so 29741. Okay, and that wasn't too much of a headache, but only because I've dealt with leaky processes before. But it has been nice to be able to demonstrate that the thing I was afraid of could actually happen, because it can be a lot more worrisome to hypothesize that there'll be an issue but not be able to prove it, and then it's like, well, maybe it'll happen. So let's see, Rust, maybe I'll go back to ChatGPT and ask it about that. And how would we phrase that? Is it possible to, let's see, attempt to lock a mutex but fail immediately if the lock attempt fails. Try lock, yeah, that makes sense. If the lock is successful, otherwise you'll get an error. So match try lock. And we'll have okay. Mutable data. Don't think it really matters which one we attempt first. And for the moment, yeah, we'll just ignore the error, which is basically what we're going to attempt. We're going to assume that we're attempting to assign a value to itself, which we're going to say is a no-op. Now, I'm not sure if there are other circumstances where this could also be flagged. It might be worth putting in a to-do comment just to flag it, but for the moment, that should be okay. Let's give that another go and see if we make it through. Nice. That's cool. I'm pleased with that. Okay, that is almost worrying how well and uneventful that went. I mean, I'm always suspicious when things that seem like they should be more complicated don't quite pan out that way. But I think that this will need a good chunk of commenting. I guess I don't need that clone there, and I probably don't need the ref either. I will go one at a time. Now the names. Let's try. That might be too much noise on a single line, but we'll see, does it work first. No, it just straight up doesn't anyway, so that kind of answers that question. Let's try it again. Yeah, so oh wait, that makes sense because I was doing the lock inside the try after the try lock, which is used to avoid the deadlock. But anyway, yeah, the names in this section leave a lot to be desired. So we've got the unlocked scope and the V that's going to be going in there. If I call it slot, maybe. Oh yeah, locked V doesn't need to be mutable. Whew. So that is that. And first of all, I will actually add a test for self-assignment now that we know that that can cause a problem if it's not, if the assignment isn't implemented correctly. Okay, so that's in a good place. Now let's take a look at the failures. Well, there's only one failure. It's operator assignment 2, and it's fairly consistently coming back with the... Okay, so it's actually the standard output is 2-2, not 1-2. I was wondering what the actual output was. So that's in operations. And so what's happening here? So we have x is equal to 1, y is equal to x, and then we increment x and we output x and y. Now this is a very important test, and it's very telling that it raised an issue. So now y and x are actually pointing at the same thing. That's a little surprising. And I feel like there are other tests that would also exercise that same idea. For example, is there a... So like basically any other tests are passing. It's just this one detail. Let's try this. Okay, so that failed as well. Interesting. So in this case, we get 3-1 as the output. Oh wait, that absolutely makes sense. That's not that's not something nefarious by any stretch of the imagination. That's just me not reading the code properly. So we have y is equal to x, and then x is equal to 3. So the value 2 is erased. So what about if we initialize y as x? In this case, we would be expecting x to equal 2 and y to equal 1. Okay, so assign 1 still failed. So, well, because it's now a new test. So this is what used to be assign 1, and now assign 1 is saying what? It's outputting 2, 2. So when we declare y to be x, it seems to actually assign the reference almost, so that they're the same variable, which is a bit odd. I'm not quite sure why that's happening, why assign 2 is working but then assign 1 is failing. But yeah, and that seems to be consistent. So it's saying 3, 3, so no matter what we update it with, the values will stay in sync. So what's happening? And how do we prevent that in the case of a declaration? Okay, so we're taking the actual box, whereas if we do that, we create its own box for this. And yeah, that should but that doesn't fix it. Definitely. I'm just going to run it again just in case. So same situation. It seems to be creating the same two references to the same box essentially. maybe what's needed is to be explicit about creating the new location. I presume that follows as well. So let's create another one of these. So I would be expecting all of the new ones to fail. So we should have 4 test failures in total. Yeah. Okay, so we probably just want our locked V and just wrap it up in a new valref with source. Might have to clone that. And could that be problematic? Okay, so now we're introducing more problems. Okay, so we actually resolved those issues with the new tests, but now we've got other issues. So let's see, it's the this functions in particular and what's going wrong there. So we'll take a look at which one, what's the top one? Bind. So we go set age 20, but it's not being reflected. why would that be the case? This is introducing, well, this is being inserted as the variables of the source, or it's being inserted as the source object. And then we're doing an assignment there. Are all the source changes problematic there? So they start off as 10 and 30, and we're setting them to 40 and 20, but that's not being reflected. And presumably the same up there as well. Now, what would be the reason for that? And what other tests are failing? List reference updates and object reference updates. And yeah, that seems like it would be related as well. So if we fixed that, we'd probably fix this reference issue as well. So it's just that the changes aren't being reflected in the source object. That could be to do with the existing implementation of the bind type functions. Bind next name. Yeah, so we have special. Could this be it? So if we have bind next on an index, then we apply that directly. Oops. And same with objects. They seem to be handled somewhat specially. And property access is basically the same thing as indexing for objects. Now for bind object and bind list, it's probably more straightforward because they delegate to bind next name, although bind object prop could also be problematic. No, it does a bind next, so we're kind of in the clear for that because it delegates down the bind chain until it gets to bind next. So I would say it's probably just these lines that are problematic, and I had a feeling that that could happen with those because they're the kind of they helped, I guess, they like in retrospect, those are kind of workaround implementations or supplementary implementations to how assignment was already being implemented. And so it makes sense that those would now be causing issues because they're kind of now at odds with the new implementation. So what to do here? So this is, I was kind of referring to this earlier when I was saying as well that some parts of this could be now made simpler, or the complexity is somewhat simplified, because now instead of having separate rules for, okay, if it's a list index, you'll use this kind of an update, and if you have a property, you'll do that kind of an update. Now it'll all just use the same kind of bind to box setup, but I would possibly need to expose that assignment as a bit of a primitive. Otherwise, I risk duplicating it in those locations. So essentially this stuff. In fact, this block essentially. So we would, instead of this, have something like that. So we have the right hand side and we would have props get name instead, and it's a bit hacky to leave it like that, but I'm just curious, will this will this work in theory at least? Well, I feel like in theory it would, but maybe there is something I'm overlooking in practice. Again, like, this is a bit of a dangerous thing as well. Okay, well, that didn't work. But now that I think of it, I'm not really using property accesses in that way in general. So let's try this instead. This would be the form that is used most commonly in the tests, I would say. And that seems to have resolved some of the issues. I wonder if I just did the last. Now they're still object ones, but I just wonder if this will help to sort one or two more of them out. Okay, and those remaining errors are just to do with the key not being found, which is actually kind of what not what I did expect, but upon kind of looking at it in retrospect, it does make sense. This function source change one, and also potentially flags something that I hadn't considered. So when declaring things as variables in kind of the, not necessarily the global scope, but the current scope, if you assign to a variable that doesn't exist, then you'll get an error. But when you attempt the same thing with a key of an object that doesn't exist, you won't get an error. And that could be kind of an interesting one. It would mean that you always have to declare keys on objects the same as you would in scopes in general with variables. So let's try I'll take a look at the source code for that file because I'm not sure what line exactly. Oh no, I won't be able to find that out. Let's try that. Just to see. I really should have finished the stream a while ago, but this curiosity is kind of... Yeah, so we're still getting the panic, even though I don't see the... Oh yeah, there's the standard error. Oh, hang on, all the... expected output is there now. Source change 3. Oh, don't do this to me. Don't do the intermittent errors. And then when you change the source code, the behavior changes. Was that one of the failing tests? Maybe it wasn't. Maybe I just updated a random test and added it to the failing test. How many tests were failing there? So there were 5 in the latest run. I think there were only 4 to begin with. Okay, so I modified the wrong one. So, okay, so this could be the issue. Value doesn't exist. And we might have to declare it before it gets used, either by defining it like this or by initializing it when f is called. Although that source change 1 is still... Let's try this. Value 1. Or value 5 to initialize it. Cool. That is a resolution to that. And that isn't, because it's different. That's very interesting. I actually kind of like that. I mean, it possibly is a bit of a pain for a scripting language in a way. It is something that I could possibly have behind a feature flag and disable if it's too much of a headache for people. But in theory, I actually kind of like that. Like, because at least in my head, I don't know, it really is a fine balance of features for scripting languages where kind of errors are concerned. So in general, yeah, it's tricky because it kind of somewhat dips its toe into the realms of kind of linting errors where the code itself is understandable, like it's clear what the author intended in general, but it could be, I guess the errors that you want to raise in scripting languages in particular, I think, are the ones where you're usually not right. At least I find you tend to write, even though scripting or scripts tend to require more tests to prove they're valid because they often don't have types and things like that, and they're being written at a fast pace. Usually those scripts also aren't really that well tested because they're just kind of gluing things together, and so you do kind of want to flag things that could be like are likely to be oversights. So I think like there are a number of errors that Golang in particular flags that I think are such a pain, such as when you import values. Yeah, the big one is declaring variables that aren't being used. And one of the problems with that is that in general, that's not such a big deal. It can kind of potentially flag that, okay, if you intended to assign something to this variable, nothing is being assigned to it. So it can kind of flag that. But it can be kind of a pain when you're commenting things out and you just want to debug stuff. But a fantastic error that Go highlights is, and maybe actually now that I think of it, maybe one doesn't work without the other, but when you when you accidentally shadow a variable inside a scope, and then if that variable never gets used, it flags the fact that you had probably intended to overwrite something in the outer scope and it didn't get used. So actually, that idea as a whole has merit. I still don't like the issue with imports, that if you have unused imports, that also flags an error. I think that's a pain. But the one that flags variables that haven't been used is a fantastic signal, because it generally does, and or at least in the context of assignment in an inner scope, 9 times out of 10 for me anyway, it highlights that I assigned to the wrong variable than I intended. So that kind of comes into discussion here of whether I also enforce this idea that values, like keys of both objects and potentially arrays, although are lists, and lists actually may make sense as well. so that you don't end up with the I mean, maybe it's a bit unfair, but I always find it baffling, that JavaScript idea that you can have a list of 3 indexes and then you can assign to index like 10. And I can't even remember what the behavior is in that scenario. Does it fill the rest with nulls, or it's just, it sits there independently and actually it acts more like an object than a list, and it can be a bit confusing, but I do kind of like this idea of requiring keys in objects to be declared before they're used as well. So that might be something that I keep around, but not today. That's today's stream finished. I think I stayed on for a lot longer than I expected, but made a heck of a lot of headway compared to what I was expecting. So that was a nice surprise. And so, yeah, thanks to anyone who's checking this out. And yeah, talk to you again. Take care.